Hello friends, I welcome you in lecture number 27 on logic. In lecture number 26, we have taken introduction of predicate. Now we know that a predicate is used to describe or to express common property of a set of individuals. For example, as we have discussed in earlier lecture, if we consider that is a red, if we consider this as predicate and if we use capital R for notation of this predicate, and if we consider this painting, this object is denoted by small p, then the statement this painting is red can be symbolized in this way: R of p. R of p represents the symbolic expression for the statement this painting is red. So here this predicate requires one object to complete this statement. Is red, if we consider is red as predicate, then to complete this statement we require only one object, therefore it is known as one plus predicate. Similarly, if we have this type of predicate, for example, is to the north of, suppose I consider this as predicate is to the north of, then in the use of this predicate, if we use this predicate to write down some statement, then we will require two objects to complete the statement. For example, if we consider one object as Canada and another object as US, then you can see if I consider this as predicate, then two objects are needed to complete the statement. Now suppose we denote this predicate by capital G. Suppose Canada is denoted by small c, United States is denoted by small s, then we can symbolize this statement in this way: G of C comma S. This means Canada is to the north of US. Here order of objects is important. If we change the order, then we will have different statement. Suppose I consider G of S comma C, then this means the statement that United States is to the north of Canada. So this is the example of two place predicate. We have discussed about this two place predicate in earlier lecture also. So if two objects are needed to complete given statement, then we have two place predicate. So in general we can talk about n place predicate also. Suppose S is the predicate, and if we require n objects denoted by A1, A2, An, then S of A1, A2 up to An is a statement, and this statement requires n objects. So this capital S is called n place predicate. So this is about predicates. Now we are familiar with predicates, that predicate is nothing but some property or characteristic or some common feature, and using that common feature we can construct the statements using appropriate objects. Now in this lecture we are going to understand the meaning of statement function. As we have discussed in earlier lectures, for example, if we consider this statement R of p, here R is predicate and small p is object, then if I consider R of p, then this is a statement. This statement is either true or false. There are only two possibilities: either this painting is red or this painting is not red. So this is having truth value, it is either true or false. But suppose I consider this statement x is greater than 3, then we cannot say anything about this statement. This statement can be true or false depending on the value of this small x variable. So whenever variable is used here, then we will have statement function. So that we understand with the help of another example. For example, suppose I consider predicate as is a mortal. Suppose capital H is the notation for the predicate is a mortal. Small b is the notation for Mr. Brown. Small c is the notation for Canada. Small s is the notation for a shirt. So if we consider h of b, then that means Mr. Brown is a mortal. If we consider h of c, then Canada is a mortal. And if we consider h of s, then shirt is a mortal. So all these are nothing but statements, either they are true or false. Now in general, I can use variable x to denote that x is a mortal. If I use h of x denotes this statement x is a mortal. Then whenever I am using arbitrary variable, here x is a variable, here I am using b, so that means b is particular object or individual, here Mr. Brown is a mortal. So in that case h of b is a statement, because this is either true or false. H of b means Mr. Brown is a mortal, but here I am using x which is a variable. So this can be true for some values of x, or it can be false for some values of x, but we cannot say anything about truth value of h of x. So this type of this type of function is called statement function, because we can see x is a variable, so x is a mortal is function, and this statement function depends on the value of x. After replacing x by some object, we will obtain statement. If we replace variable x by some particular object or individual, then we will get statement. So that type of expression in which by taking particular value of variable x we get a statement is known as statement function. So here this h of x is a statement function, and I have written here h of x is not a statement, but it results in a statement when x is replaced by the name of an object. So the meaning of statement function of one variable is defined to be an expression consisting of a predicate symbol and an individual variable. That is, suppose p is the predicate, then this predicate symbol, and in the bracket we are writing variable, then this is the statement function of one variable x, and it is an expression which consists of predicate symbol and an individual variable. And because here we are not having any logical connective, therefore it is called simple statement function. If our statement function involves any logical connective or logical operators, then that is going to be a compound statement function. So that is the meaning of this word. Simple statement function means it is not having any connectives. So again I repeat, a statement function is a expression involving predicate symbol and variable such that it results in a statement when x is replaced by name of an object. And statement function is also known as propositional function. Suppose I consider mx as x is a main, hx is another statement function, x is a mortal. Then here also we can construct compound statement functions using logical connective. Here I have used AND operator, here conditional statement, this is negation of hx, this is disjunction of these two statement functions. Here I have taken one example. Let p of x denote the statement x is greater than 3. What are the truth values of p of 4 and p of 2? Here I have written that p of x denote the statement, but this is not statement, it is statement function. But sometimes they are writing only statement, but that is also fine. If variable is used, then you understand that it is a statement function, and if particular value is used, then understand that it is a statement. So here px denote the statement that small x is greater than 3, and by taking particular values of x we will obtain statements. So here they have asked to check the truth values of these two statements by taking x equal to 4 and x equal to 2. So suppose I consider x equal to 4 here, then I will obtain 4 is greater than 3. So now this is a statement, this is statement function. By taking x equal to 4 I obtain 4 is greater than 3, and this is a statement, and we know that 4 is greater than 3, therefore here truth value is capital T, which has truth value is true, or we can simply denote it by capital T. If I take x equal to 2, then I will obtain the statement. Here I will put now x equal to 2, so I will obtain 2 is greater than 3. So what is truth value here? Truth value here is false, because 2 cannot be greater than 3. So this is the example in which we have statement function, and by taking different values of variable we obtain different statements. We can have statement function of two variables also. For example, suppose g of xy denote this expression x is taller than y. So if both x and y are replaced by the names of objects, we get a statement. Therefore gxy is a statement function of two variables. And suppose we consider particular values of x, m represents Mr. Miller and small f for Mr. Fox, then if I take x equal to small f, y equal to x equal to m and y equal to f, then here x is m for Mr. Miller is taller than Mr. Fox. And if I interchange the order, suppose I take x equal to f and y equal to m, then Mr. Fox is taller than Mr. Miller. So we can sometimes construct statement functions of two variables by using statement functions of one variable also. For example, mx denote that x is a main, h of y is a statement function in which y is variable, and h of y represents this statement y is a mortal. Then we can construct the statement function of two variables by joining these two by AND operator, that is conjunction of these two. That means x is a main and y is a mortal. So this is about statement functions. If we have one variable, then we have statement function of one variable. We can have statement function of two variables also, and we can have statement function of three variables also. Suppose I consider g of xyz represents x equal to y plus z, then this is statement function having three variables. For example, if I consider x equal to 3, y equal to 0 and z equal to 2, then I will have 3 equal to 0 plus 2, and you can see this is false, so its truth value is f. Similarly, if I consider y equal to 1, then I will have 1 plus 2 here, and truth value will be capital T. So this is about statement functions. All we have to understand is that if I am writing p of x, then this is nothing but statement function, and if x is replaced by some particular value, say small a, then we will have statement if p of x is a statement function. P of x is a statement function if by taking particular value of variable x we get a statement. So this is all about this session. We will continue with these predicates in upcoming lectures. Thanks for watching.